Pluto has always been one of the most captivating and mysterious objects in our solar system. Since its discovery in 1930 by Clyde Tombaugh, Pluto has puzzled astronomers with its unusual orbit, small size, and icy composition. For more than 7 decades, Pluto held the proud title of the 9th planet until its reclassification as a dwarf planet by the International Astronomical Union in 2006, a decision that still sparks passionate debates today. Despite its change in status, Pluto continues to fascinate both scientists and the general public. Why? Because Pluto is unlike any other world we've studied, and every new mission or observation seems to reveal more surprises. Now, with the James Webb Space Telescope, JWST, the most advanced space observatory ever built, humanity has gained a powerful new tool for studying distant planets, galaxies, and cosmic phenomena. While much of the attention has focused on JWST's breathtaking deep space images, scientists have also been using it to study nearby objects within our own solar system. Recently, the telescope turned its golden mirrors toward Pluto, and the discoveries it made are stranger and more intriguing than anyone expected. This video explores what JWST found when it looked at Pluto, why those findings matter, and how they could reshape our understanding of the outer solar system. When NASA's New Horizons spacecraft flew past Pluto in 2015, it changed everything we thought we knew about this distant world. Before that, Pluto was little more than a blurry dot in telescopes, but New Horizons revealed a surprisingly complex planet-like body. Towering mountains made of solid water ice, vast nitrogen plains, bizarre reddish regions, and hints of glacial movement. The iconic heart-shaped Tombaugh ratio became a symbol of Pluto's beauty and mystery. Data from the flyby even suggested that Pluto might have a subsurface ocean and an atmosphere far more active than expected. But New Horizons was only a flyby mission. It gave us just a quick snapshot. To truly understand Pluto's long-term behavior, chemistry, and climate, astronomers needed more powerful instruments. Enter the James Webb Space Telescope JWST, launched in December 2021, is designed to observe the universe primarily in infrared wavelengths. This means it can detect faint heat signatures and chemical fingerprints that are invisible to traditional telescopes. By aiming JWST at Pluto, scientists hope to uncover new details about its surface composition, atmosphere, and potential internal activity. And what they found confirmed that Pluto is not a static, frozen relic. It is a dynamic, evolving world with secrets still waiting to be uncovered. One of the most striking revelations from JWST concerns Pluto's thin and hazy atmosphere. Earlier studies suggested that Pluto's atmosphere is composed mostly of nitrogen, with traces of methane and carbon monoxide. But JWST's infrared spectrometers detected strange variations in the way these gases behave. The atmosphere isn't evenly distributed. It appears to collapse and expand, depending on Pluto's position in its long, 248-year orbit around the Sun. This means that Pluto's climate is far more chaotic than once believed. Imagine a planet where the atmosphere can literally freeze out, fall to the ground as snow, and then reappear centuries later as temperatures shift. JWST also detected unusual haze layers, possibly caused by complex photochemical reactions in Pluto's upper atmosphere. These reactions may be producing organic molecules known as tholins, which give Pluto its reddish hues. Equally fascinating are JWST's observations of Pluto's surface chemistry. Using its infrared instruments, the telescope detected a wider range of ices and organic compounds than New Horizons could. While scientists already knew that Pluto's surface contains nitrogen ice, carbon monoxide ice, and methane ice. JWST revealed signs of more complex hydrocarbons and exotic ices. These molecules may form when sunlight interacts with methane, creating organic compounds that slowly accumulate on the surface. In other words, even at the edge of the solar system, Pluto is generating complex chemistry that could resemble the processes that took place on early Earth. Some researchers suggest that these compounds may even be chemical precursors to life, though Pluto's extreme cold makes actual biology highly unlikely. Still, this discovery raises profound questions about the universality of organic chemistry in the cosmos. Perhaps the most surprising finding from JWST is related to Pluto's potential subsurface ocean. For years, scientists debated whether Pluto could maintain liquid water beneath its icy crust. New Horizons hinted at this possibility when it revealed geological features that looked like cryovolcanoes and tectonic structures. Now, JWST's thermal observations provide further evidence that Pluto might still be geologically active. Certain heat patterns suggest that Pluto's interior could be warm enough to keep an underground ocean from freezing solid. If true, Pluto would join the growing list of icy ocean worlds, such as Europa, Enceladus, and Titan, moons that are now prime targets in the search for extraterrestrial life. While Pluto itself may not be habitable, its potential ocean demonstrates that even small, distant worlds can remain active and intriguing for billions of years. Another highlight of JWST's observations involves Pluto's iconic heart-shaped region, Tombaugh Regio. The western lobe of this feature, known as Sputnik Planitia, is a massive basin filled with nitrogen ice. JWST confirmed that this ice is not static, but actively reshaping the surface through processes similar to glacial flows on Earth. This means that Pluto is not a dead world. It is still evolving. The presence of moving ice suggests heat transfer, internal activity, and cycles that we never expected from such a small, distant object. Combined with evidence of mountains, valleys, and possible cryovolcanoes, it paints a picture of Pluto as one of the most dynamic objects in the solar system. So, what does all this mean for planetary science? For one, it challenges the way we categorize and understand planets. Pluto may be small, but it is astonishingly complex. If a tiny world at the edge of the solar system can have an atmosphere, glaciers, organic chemistry, and possibly an ocean, then our definition of what makes a planet alive geologically must expand. It also raises new questions about the Kuiper Belt, the vast region beyond Neptune that is home to thousands of icy objects like Pluto. If Pluto is this complex, what about its neighbors, such as Eris, Haumea, and Makemake? Could they also harbor oceans, dynamic geology, and strange chemistry? JWST's observations of Pluto are just the beginning of a new era of discovery in the outer solar system. In this video, we'll take you step by step through what JWST found when it looked at Pluto, its atmosphere, its chemistry, its possible ocean, and its glacial activity. We'll also discuss what these findings mean for the future of exploration. Will NASA or another space agency send a dedicated orbiter to Pluto in the coming decades? Could Pluto one day become a test case for exploring other icy worlds? And how do these findings connect to the search for life beyond Earth? Pluto may no longer be officially called a planet, but as the James Webb Space Telescope has revealed, it is far stranger, more complex, and more fascinating than we ever imagined. By studying Pluto, we are not only learning about one distant world, we are uncovering clues about the history of our solar system,